Hey, this is Mike with Fancyfoam Models. Going to do a quick build video for the NutBall. This was originally designed by Gold Guy on RC Groups. There's been lots of different models out similar to this, but I think he had models going way back, even possibly to the gasoline days, before we did electrics and that kind of stuff that were similar to this. Anyways, he had a Dihedral version of this that was very popular, and there's still a pretty good following for it. I really like working in EPP and wanted to do an EPP version of it, so I reached out to him, talked to him a little bit about what I wanted to do, and he was real positive about backing me up on that and encouraging me to go forward with it. It's a rudder, elevator, throttle control aircraft. We've got one built here. Just 2 servos, and then on the bottom I've got speed control, receiver, up front's the motor. But we'll get into the build real quick. The parts that you get in the kit are the right and left hand sides of the main wing, the elevator, the vertical stabilizer, and the rudder. There's a doubler that goes on the front of the aircraft on the bottom. These are optional. These are for the landing gear, to mount the landing gear underneath, along with the wheels, some wood supports or plastic, depending on what I have in the kit that day. This is a 2mm carbon rod that's used for the landing gear. Again, all that's optional. And then a 1.5mm carbon rod that's used for the push rod. There's a little bag that has the push rod parts, control horns and such, and then there's a plastic motor mount. For this to go together real quick, the very first thing we're going to do is just glue the 2 wing halves together. I would have preferred to have this ship in one piece, but I don't have a box that ships well that handles this width. So just an easy split down the center. Foam tack glue is what I sell and what I recommend. It's kind of the best glue out there for EPP. A lot of people are used to using CA super glue. I don't like using a rigid glue like that on EPP. A flexible foam, I like using a flexible glue. The other reason is we use the glue for hinging the elevator and the rudder. But what I'm going to do is just apply a decent sized bead down one side of this. Get this little tab here at the back, and then I'm just going to push these 2 sides together, slide them around a little bit. I'll pull it apart, and then I'm just going to take my finger and kind of rub in the glue. Make sure I don't have any chunks of anything on there. I'm just kind of rub this glue into the surface a little bit. When I slid those together, it should have applied about half that glue to the other surface here. And just in that time that it's sitting, this glue is tacked up a little bit. I'm going to line up the leading edge, the trailing edge by the hinge line, and then also the slot here. Make sure everything lines up real good. And then I'm just going to push those pieces together. Now, I can peel them apart, but you can see they're already sticking. It takes quite a bit of force to actually pull them apart. So that's basically set. We'll let it kind of lay flat for a little bit. That'll help it fully set up. It just takes a minute or 2. 10 minutes I consider for full cure, but just within a couple minutes. I've had parts where I've broken them while flying, put the glue on, stick it together, and immediately fly it. It holds it quick enough that I can just use it right away. While that's setting up a little bit more, I'm going to go ahead and hinge the rudder. So on the rudder, this edge, which is the back edge of the vertical stab, and the forward edge of the rudder are beveled. You can kind of see that there. And those bevels will just go together. I'm going to take the rudder and just apply not a large amount of glue on this, but a small amount. About as small amount of glue as I can put on there, but have a continuous bead. So it ends up being maybe about the same size as that 1.5 millimeter carbon rod. A little bead of glue on that edge there. I want it all the way down. And then I'm just going to take these two edges where the 2 points of that bevel are, and you can do this flat on the surface, that makes it a little easier. And I'm going to push those together. And you can see that already holds it, but you know, it hasn't been very long, so I can pull it apart. But I'm going to lay that down. I'm going to just take my finger and kind of smooth out any glue that has squished out of that joint. I'm going to fold this back on itself, and I'm going to rub this glue on the inside of the hinge as well. Fold that back, lay it down, and make sure to push that together. And then I'm just going to set this aside and let it cure. I want to make sure that that surface is nice and aligned well, and that those points are touching each other. Okay, I'll set that aside. And then I'm going to come back to this main piece. The next thing I can do on that is flip this thing upside down. And this is where the doubler goes on. Now, the motor mount slot in this doubler is not straight. It is angled. And what we want is when the airplane is right side up, we want that slot angling from the back left to the front right. That tilts the motor to the right and gives us a little right thrust. This model really does need that right thrust. Almost, pretty much all of my other models, the motor is perfectly aligned, both left to right and up and down. They're just straight. This model really needs some right thrust and then also some down thrust. And I'll show you, well, I'll show you that in a little bit when we go to put the motor mount in. So anyways, what I want to do is with the body right side up, and we can tell right side up because these grooves on the side are on top. We're gonna glue that up and give us our dihedral, but we'll do that after I put this on. And so with this laying on top, if I have that motor mount slot angling off to the right, and then I'm going to move that to the bottom of the aircraft and then flip it upside down. And I'm just going to use the foam tack again. I'm going to put a bead, pretty heavy again this time, all the way around the outside. I'm going to go around each of these openings. And then I'm going to add some more glue kind of in the big areas so that it all sits down nice and well, gets stuck really good. Okay, so this is going to go on top. The leading edge will line up, and then also these are the servo openings. Those are going to line up as well. So using the leading edge and the servo openings, you can get that lined up. Again, I want that motor slot running off to the right, you know, to be back and to the right when it's upside down facing me. I'm going to put some pretty good pressure to transfer that glue across, and then I'm going to flip this over. And again, I'll just use my finger to kind of smear the glue around. This actually gives us a little more glue area, a little more foam that has glue on it, and then I'll do the same down here as well. Spreading this out also helps it cure a little bit faster as well. So line up the leading edge, line up the servos openings, press that back down, and now it's actually stuck fairly well. I don't want to pull it off yet or anything. While that's setting up, we can talk about landing gear. That actually would be one of the last things we would put on, but we can go ahead and talk about it now. The 2 millimeter carbon rod, it should be the distance from the outside of these slots. So these slots are where the landing gear attaches at. They go in like that. So this rod's a little bit long. Typically they'll be a little long when they come in the kit unless I happen to trim it to the right size. I'm going to go from the outside to the outside of the slot. I'm going to take a box cutter or another sharp knife, and I'm going to score, just pushing down on the knife and rolling that carbon back and forth. I'll do that several times. That'll score that carbon, and then if I kind of bend it a little bit and twist, it'll just pops right off. So the gear, I'll call this a gear leg. Those two will end up like that. This plywood mount, the foam's not strong enough to hold that by itself, so this plywood mount is going to slide over the carbon rod. These holes are a little tight, so I'll probably would take a drill bit and open that up. In this gear leg, the laser cutter actually cuts a little hole in there for the carbon rod. So I'm going to line, usually what I'll do is I'll take this plywood and I'll slide that on the carbon, then slide the carbon in there, and then I can slide the plywood up, and I'll just use more foam tack to glue the plywood. And that lines up fairly good like that. The plywood will just glue to the inside. That glues on the inside edges of those. There'll be a little 1-inch piece of just silicone fuel tubing. I take that and I cut it in half. That slides onto the carbon rod. The wheel slides on next. The plywood goes on after that, and then that goes on there. And once that plywood's glued on, you can slide that fuel tubing. You don't want it tight, but you want to hold that wheel near that edge. And so it'll sit like that. Finished, it's going to look like this. So you have the foam, the plywood. In this case, I actually spaced the wheel off of the plywood a little bit with a small piece of the fuel tubing. I cut maybe I think I ended up on this one, I cut it in 4 equal pieces. So you have a piece here and a piece here. I think I was having trouble with that rubbing a little bit. And so that's how to prevent that. This is my prototype, so I didn't actually make the gear leg long enough. I had to move this down a little bit so the prop didn't hit, but the production versions, these are longer. But anyways, there's the landing gear setup. And as you can see, this is here's the vertical stab, and it actually sticks through, and this is just what would be the tail skid on the airplane. Now, if you do opt to not use the landing gear on this plane, which does make it lighter, some people don't want to mess with landing, they'll just hand toss it and then land it on its belly. Once the vertical stab is glued in, you can just cut this tail skid off. Just cut it flush with the bottom of the aircraft. Alright, so main wing is glued together. We've got the doubler on. We've hinged the rudder, and now that it's been several minutes, you can see this flexible glue, but it holds really good. So the next step is going to be to put the dihedral, so the wing tips are going to be bent up. First thing I'm going to do is kind of bend this down a little bit and rub my finger in there, and any little beads of foam that are loose in there, I want to kind of rub those out and then kind of blow that out. And then I'm just going to take and put foam tack on this inside edge. And again, this can be a thicker bead. You kind of want it closer to the surface on this. The bottom side will be fine by itself, but you want to really hold near the top surface there. So I put the glue in there. I'm going to bend that up. That gets it on both sides. I'll flex it a couple times. That'll move it across. I'm actually going to do both of these at the same time. So I'll put in a bead of glue here. Again, push that up. Now with holding that up, I can run my finger down there, and any glue that is squeezed out, I can kind of press that back into the foam. And if I just hold it with those up for a few minutes, it's going to stay there. So I'm going to wedge this into my workspace there for now, and that'll just kind of hold it while that glue sets up. From here, we'll talk a little bit about the electronics. The only thing I have left on the airframe is to glue the elevator on. That's going to be done the same as the rudder. You put a small bead, about 1.5 millimeter diameter, across the beveled edge of that foam, and then that's going to glue in place right on the trailing edge of the wing, which is also beveled. The servos, just glue those in with foam tack. They'll go one on each side. The rudder is on the left side, the elevator on the right. These are the parts that I make for my trainer planes, which have less adjustability, but they're a lot easier to put together. So this is what I call a flexible push rod end. That's what's both here and here. They're sized to fit, if I can find a servo here. So they fit right on the servo arm, and you just glue that in place. So you would take this opening here, put a little bit of foam tack glue in there, and slide it on the servo arm and let that glue in place. Now, you want to make sure that they're facing the right way. This can flex all the way back on itself in one direction, but in the other direction it can only flex about 45 degrees. So we want to make sure we can do a 90-degree bend in that to go back towards the control horn. Now, there's 4 of these. The same one also fits on these control horns. You just glue those in place, and then the control horn glues into the slot that's cut into the foam. So you'd put a little glue in the slot and maybe on the bottom side of that control horn. Set that in place and let that cure. Once the servo's in place with its push rod end, the control horn's in place with its push rod end, then you can take your carbon rod and you'll measure a piece. It can be a little long. It actually can stick out on the servo end a little bit without hurting anything. If it's a little short, as long as it's, say, 3/4 of the way through this section of that push rod end, you're fine. Find out what length you need. Do the same thing I did with that landing gear leg or axle, and I'll just take my knife and I'll roll that, scoring that. I'll bend it slightly and twist, and that'll snap it, and that'll give me my push rod length. The last little pieces that are in the push rod set are these push rod guides. That keeps this push rod from being able to flex around, flop around, makes a nice, good, stiff control rod assembly with these in there. And there's actually, this thing's done now, there's actually a little hole cut in the foam on either side of those, and that's where those goes. And again, those just glue into place. You'll put some glue in there, and then you'll push them in deep enough to where this push rod is straight. It's not bowing up or bowing down. It's just straight front to back. So Last thing is the motor mount. So we talked about how we want the motor to angle to the right. Let's get this down where you can see it. We want the motor to angle to the right. We also want a little down thrust. So as you can see, this stick mount for the motor is flush in the back, and then it's actually resting on the foam on the front, and this pushes the front of this motor mount down to give it a little bit of down thrust. So because of the angle on the slot, we have some right thrust, and because this motor mount is going from being buried in the foam at the back to resting on the bottom of the foam on the front, and if I show you this part here, this slot doesn't go all the way to the front. That motor mount stick will actually rest on top of the foam here. Let me get that out. So here's the stick. The back end will go into the slot, and the front end will just rest on top of the foam there. Again, apply some glue in there, apply some glue around here, glue that in place, and then come back in and add some more glue to the sides here in that joint there to really let it hold that in place. I do get questioned a little bit because the stick mount comes with this little disc. The motors come with a little motor mount like this. This goes on the back of the motor, but in this case we don't actually use these two parts, the disc or the motor mount. This motor tube actually slides into that stick. Now I'll take my knife and I'll cut this motor mount stick. I'll just cut a slot, or I could take a Dremel cut-off wheel and just cut the slot back maybe about 1/2 inch. That makes it easier to get the motor in and out. But once you, there's a bolt and nut that is used to clamp the motor in place. Once you tighten that up, that slot there doesn't affect anything as far as the motor being held into that stick motor mount. So get some of this cleared out of the way. The finished assemblies like this. We've got the bolt and nut on this side that are clamping the motor into the stick mount. And then also what comes with the motor will be 2 screws and this black plastic piece. The black plastic piece has a couple of machined sides on it. The smaller of the two actually fits into the hex opening in the back of the prop. And as you can see on here, when you put the screws into either side of this, then you can stretch either the O-ring that comes with the motor or the prop saver bands that I sell alongside the kit. That O-ring stretches from the one screw around the front of the prop and then to the other screw and holds that prop on the front there. What that also allows is if you come in and land nose first, that prop can swing out of the way, results in less broken props and less burnout motors. That's the basic construction of this airplane. As far as trims, the rudder is going to be pretty much straight. The elevator, I would start out with just maybe 1/4 inch of up elevator. You can launch at about half or a little more throttle and it should just fly out away from you. It turns really well. You can use as lot or little of your rudders you want to make it more or less controllable. Starting out you want less throw, but this thing can actually do rolls because of the design with the polyhedral and the rudder. And so starting out you'll actually want less elevator and less rudder to make it easier to fly, but then as you get better you'll probably crank it all as much as you can get to really just goof off with the airplane. So anyways, that's the basic construction of the NutBall. It goes together really quick and it's a fun little plane to fly. Thanks for watching.